Done. Hi. So today is second Wednesday of the course. That means we start a new class. Today is going to be an introduction to what is CAD, that's computer-aided design. And we will have an invited guest that is Victor Van that will come around 12 and will give you a tutorial on how to use Blender. Blender is an open source software that is 2D and 3D modeling software, and it's quite good. And in the late years, have been a big improvement of the open source community to actually push for this software, and it's widely used even for making animation movies. So it's really powerful. It's not just a non-developed software. It's really, really powerful. MDev will have also the class on Fab Academy in the afternoon with Neil, as always, at 3 p.m. So 3 to 4:30, we have the review that Santi and Joseph, I don't know who will go up to it, as we swept. From 4:30 to 6 is a Neil class, like more deep advanced class on computer-aided design. And then we have from 6 to 7, the lab cleaning. It's already clean, so we can go directly for a beer, almost. I wish the bars were open. So where we can find information, as always, if you don't know where to find information, remember this path, Fab Academy 2021. I will repeat this at the start of every class because you always ask where I can find all the information. Falda Barcelona and local documentation. And then to jump onto the main local documentation, we go to weekly classes and computer-aided design. That is today's kind of lecture. So here you can see the videos from last year recording of Neil. And we will go a little bit of what is CAD. Can you raise your hand, the ones that have or know what is CAD? Okay, a lot of people. Okay, the basics we have set up. Have you ever, know the difference between a vector and raster program? Okay, not that many hands on the air. So first, let's go a little bit of what is computer-aided design. Image compression, format size. Here. Computer-aided design has been since the start of people in the waiting room. Since the start of the computers has always been something that all designers, engineers have always taken profit for. Why? Because especially the ones that come from the field of design or architecture, like an engineer, the plans before were made by hand. That is clearly really annoying because you first need to draw it by hand and then with like architectural plans or pilots to actually have the good footprints. What happened when you need to do a modification? That was really annoying. The good point of having the computers, and of course, everything started with a 2D design, not 3D, because that requires more computational power, allows to live change the plans and have like automatic databases updated. Nowadays, that is even changing and have like different kinds of modeling. For example, we have BIM modeling, that is Building Information Manager, that basically has interconnectivity between different files and different kind of programs to actually have live changes along if you change a line or where, for example, a wall is located. Also, the pipelines, the engineering parts of the building also get updated online. So that makes live changes on 3D models, like complex 3D models, way more affordable, and you can update it way faster. There are a lot of types of computer-aided design types, and a lot of people is coming into the waiting room now. And for example, we have also what we call animation, that most of you, I would say like 99% of you, will have seen a Pixar movie. Actually, in their case, they created their softwares because the software for animation for live rendering didn't exist. When you go to animations, or why this presentation doesn't work, for CAD, we have sketch-based modeling. That is what we commonly state as the initial parts of the CAD modeling. that it was mainly used for creating from a 2D file or create a 3D file from a 2D file. Before we jump into 2D, 3D, I want to start with the simpler approach, that is 2D modeling. When you go to 2D modeling, there are different types. There's something that is really important to understand, and we have a kind of similarity also into 3D modeling. We have what is called vector design and pixel design or raster files. Does anybody knows the difference between a vector and a pixel without reading the screen? Yeah? Can you? Yeah, raise your voice. Yeah? I don't with the mic.
Well, pixel sort of information, and a vector is a different. Well, I don't know if I can explain exactly the difference. I work with Illustrator and Photoshop. I know how to handle the different type of images. I know the way that they work, but I can't explain the technical part of how what the difference exactly is.
So basically, when we design 2D, we'll go later on 3D, we have what is called vector design file or vector design. So what we are designing is lines with properties. Those lines or curves are basically mathematical equations. So you are not actually drawing physically the line, you are defining a set of rules. It's what we would consider is not visual scripting, because we are not scripting per se, everything is done in the backend. So in this kind of programs, what we do is use a GUI, that is a GUI, user interface. So for example, programs like Photoshop or Illustrator, they are visual representations of what we are doing in the computer. So when you draw a line, or what is the equation actually of a circle? As you see, it's x2 equals radius. That's the simplified equation of a circle. So when you draw a circle, you actually put a line of code in the program that is the definition of the circle. That circle doesn't exist per se. What it has properties. For example, we can set up a line weight, that is actually how much and what is the thickness that we are visualizing for that circle. Or if the circle has a hatch, this one is a solid hatch. So this solid hatch is not drawing in the file. What is done is visualized for you. So the files for vector files usually are much lighter files and has a big improvement. They are not defined by data. Data that is stored. For example, a pixel is the unit of a raster. We can say that, for example, it will be the millimeter. Actually, it's variable, the size of a pixel depends on your pixel screen, but it's a square that contains a color information. So a raster file is defined by amount of pixels. It means it's a grid of pixels. How many pixels we have? We can have like 1 million pixels, 2 million pixels. Right now, that have at least 8 megapixels, and they contain information about the color. What is the difference for a raster file or a pixel file? We are working not on processing mathematical equations, we're working on actually storing a large amount of data. So the first difference is how they work in the core basic. One, basically, the computer is reading information of this square is located in this position and has this property of color. And in vector, what we are doing is defining equations that define geometry, and they are much faster to calculate. So vector, by general, are much faster to calculate than pixels. And we will say why we have pixel files. Because most of the capturing devices that we have imagined and created so far produce pixel files. For example, a photographic camera, a video recording camera, a scanner, what it does is takes small portions of information that are like, is the diode sensors of the camera, and translated them into pixels. So you will say, okay, larger files, more megapixels will be more definition, no? That's true. That's not completely true when you relate to camera devices, but it's completely true when you relate to file size and file quality in general. So a pixel file in general is way more difficult to edit. Imagine that basically you have, actually I will show it with a video that I like always to show. Let me look for it. So this is a Mythbuster video that shows the difference on how computer process information. So basically computers, they think linearly and they do a step of instructions. Now, like a lot of computers have what they call multi-core, and they can process different things at the same time. They can do it in 8 lines or 4 lines of information, so they can have like 4 brains thinking individually, but with having one way in color, one goal. So a computer, when it has to show a raster file, basically is doing this. It's reading 1 pixel, that will be these dots. This is kind of silly information. A CPU thinks like that. So what happened and how we can proceed with raster files and work like as we do right now in any computer aided software, like for example, Photoshop, that is a raster design program. What we use is a GPU. GPU is the part of the computer that is completely dedicated to work in multi-threading. So it's part of the computer that is dedicated to do a lot of tasks, but really, really small ones. And that actually is the best purpose for raster file. So when you work with raster files, one thing that is quite important is to have a GPU, because we are working with large and really large amount of data, but processing it about the amount of information that each data has is really small. So imagine that the small first machine gun was the CPU, that in case of a vector file will be super fast to process because calculating mathematical equations is really fast. And if you want to process a raster file, what you want to do is having a GPU that basically does this. So, okay, almost there. So when you have a file, what will be more easy to edit? A raster or a vector? In general, a vector is way easier to edit. Nowadays, just imagine that you are in Photoshop and you want to Photoshop or GIMP, and you want to change just the eye, the color of the eye. You need to paint manually in some way, kind of all these small pixels and change the values of those pixels. Meanwhile, modifying the eye, and instead of having a circular eye, you want to have a ellipse eye. I don't know, you're an alien or a cat. You can modify just by changing the point location that defines the equation. That is the definition. That usually is like grab points. Depends on the software, they are called differently. So one of the big issues that we have with raster files is enlargement and file size. You all have seen like the CSI, like TV drama, that they say enlarge the picture, enlarge the picture, enlarge the picture, and they show more definition. Actually, that's not impossible. There are machine learning algorithms to actually are trained to kind of improve these things, not in the way they do in the TV, but a little bit. So what happened when you have a square and you make it bigger? What happened? The square doesn't reduce and subdivide itself. What it does is you're making the square bigger. What happened? There is a point that you cannot make enlargements that are good enough. That's why in the late 5, 6 years, now is everything more calm. A lot of the phone devices and camera devices have what we call the megapixel war, that they were basically increasing the amount of pixels on the phones and the cameras because actually more pixels is better. Yes, there is no doubt about it. But there is a moment that you don't need that many amount of pixels. For example, at 300 ppi, a 24 megapixel image is a A0. You know A0, the paper formats? It's more or less 1 meter wide image. Are you ever gonna print that image? No, it's too much. So basically you are just wasting memory of your storing devices. Meanwhile, in vector, for example, you can always enlarge. Why? Because the line, the drawing, doesn't exist per se. You are just visualizing an equation. You are seeing the equation in your computer, but the equation, if you augment it endlessly to the infinite or reduce it to the infinite, the equation is going to be still the same. So the line and the line weight is going to be always perfect. So usually for illustration, that you use vector files because they are easy to modify, they are faster to compute, but they have a bad point. What is the bad point? So humans have just learned how to process images through a raster method, even for input or for output. When you have a printer, like a house or photographic printer, what you do is you are printing on a photographic paper. If you augment with a microscope, what you have is actually, it's not pixels, it's dots. It's little dots of ink that if you make them small enough, they give the perception of continuous image. So basically we have like the capturing device that now that there is digital, it's called pixel. Before in the film photographic cameras, it was like silver alloys, I think it's alloys. I know the name in Spanish, sorry. So there are the small triangles that capture the light, and these triangles in the photographic film is what we actually can print and get and capture the instant of that moment. So when you want to print, you always have also to output to a raster file. So what you do, and a general good working workflow, is as much as you can, always stay with vector, and only for the final part of the file, try to rasterize it, in case you want to print it. If you never want to print it, it's not good to vector, what we call rasterize a file. We can go, it's really easy to go from a vector file to a raster file. Going from a raster file to a vector file is not that easy. And that process is actually nowadays way better. Like I will say that in the last 2 years, this process has improved a lot. But what we do when we rasterize, when we vectorize a raster file, we do approximations. So you see here that we have basically 1, 2, 3, 4 colors that are quite easy to distinguish. So how a vector will be created here will be one triangle that is defined by the red, one triangle that defines the blue, one triangle that defines the yellow, for example. They are really simple mathematical equations, and we can define color properties for each mathematical equation. What happened? Where does the red and the blue finishes? There is a moment that is just a value in between, this kind of purple one. So basically, we need to have the tracing definition that is established if a color is the borderline and where is the borderline between two different colors. So those are approximations. So the computer, even you choose to do a lot of approximations on different amount of grading colors, or you just choose to simplify. If you choose to simplify, what you will define is have this line will be a zigzag that is actually hover between the different colors. One for the red, one for the blue, and one for the purple. If you simplify and do it in a minimalistic way, you will just have one line that is letting the purple color on the red zone or the purple color on the blue zone. So vectorizing a raster file is usually something that is not really accurate. When we talk about pixels, We have the resolution and the density. One thing is not strictly related to each other. For example, why have you ever used a DSLR camera, a reflex camera, or a kind of semi-professional camera? They are huge, no? They are bulky, and more or less nowadays they have the same amount of pixels, megapixels, as the camera states, as the phones. But the phone camera is really small. How come? How does it come? That we need to focus on how the cameras work. That is, so this is how basically a digital sensor works nowadays. We have a grid of photodiodes that are similar in a way to the LEDs that you might have used. The LEDs are small bulbs for lighting, but they do the opposite. They are sensors, and they are really, really small. So as you see, and you can maybe already tried, there are LEDs that are really huge, and there are LEDs that are really, really, really small, no? For example, the ones that we see on the notification device on our phone, usually is on the top, it's a little light, it's a super small LED. Meanwhile, for example, this is a big LED. What is the difference? The bigger the LED, the more light it's able to capture. So in general, and this is a golden rule for cameras, larger photodiodes means more ability to capture in low light conditions. So that's one of the main reasons why phone cameras, usually they work really bad at night because they have the same amount of pixels, but in really way smaller space. That means the size of the pixels is smaller. That means they are able to capture less light in dark conditions. Meanwhile, large cameras, like medium format cameras, or like any professional DSLR, they are really huge because the sensor is not the same size as a phone, but quite similar in the inside. Usually they are around 2-3 centimeters wide just for the sensor. That means they have the same amount of pixels, but each pixel is bigger. And then is what we have the resolution and the pixels per inch. Pixels per inch shows the amount of definition. That is, if you have in 1 inch, that is 25.4 millimeters, for the ones that are not really familiar with imperial. If you have 10 ppi, you have 10 pixels. Those photodiodes or pixels will be bigger. That means they are able to capture more light. So it's a sensor, in case of camera sensor, that is able to capture more light. What happened? We cannot make really big definitions or accurate definitions, for example, capturing a circle. If you increase the PPI, for example, to double, you have way more pixels. That means you are able to define a more soft and rounded circle. But if you do it in the same amount of space, your diodes will be, in case of a camera, will be smaller. That means your camera is able to capture less amount of light, and in general, they create more noise and reduces the camera size. And we have the resolution. So, and that means is the total amount of pixels for the whole image, not per distance. So what we do is measure the total amount of pixels in an image. And that gives the actual photo size. So to give you an idea, screens or everything in the internet, nowadays that's changing, but everything in the internet is in around 72 pixels per inch. And then you will say that's a quite low resolution. Yes, but why is that for? To reduce the total amount of data being transmitted through the internet, to reduce actually the bandwidth that we need to see and transfer the images between computers. A photographic camera device usually captures around like 300 ppi. We consider 300 is, we'll see the best eye that a human can have will be around 300. Actually, humans stop seeing pixels at a definition of 250, 260 pixels per inch. So let's say you are, oh, most, like some of you are in your 20s, your eyesight is perfect, your family has perfect eyesight for generations. That will mean that if you have like eagle eyesight, you only will be able to see to a maximum of 200 something, 230 ppi. I cannot state a clear value because that depends on the human that is actually watching the image. So most of the capturing devices, the semi-professional or professional capturing devices, they capture at 300 ppi. But the average sensor only sees slightly small difference around like 150 ppi. For example, a professional printer, or I will let's state your house printer, usually prints at a definition of 90, 100 ppi. So actually the resolution is quite low. If you go to a professional copy shop and you use a professional graded printer, the definition that you get on the prints are around 130 to 180. If it's a really, really good professional printer, like photographic type, you are getting close to 250 to 160 ppi. So I will make a lot of comparisons on the phones because we have clear examples, everybody has one. But when you buy a phone, they always advertise. The resolution of the screen is like 400 ppi. Actually, that's quite kind of useless. It's like basically they are just announcing big numbers because that makes big sales. Like humans cannot see higher than 300 something ppi. It's impossible to see. And what you have is actually you need to process that amount of ppi because what we are working with upstream is a visualize of a raster file. It's a visualization of a raster file. So basically more pixels, it means you need to process more amount of information. That means you need more power on your device to actually process the amount of information. So on the TV screens, we have kind of the same, like we have UHD camera, like TVs, like 4K, 8K, 12K. That's important on not only the distance that you see the image, but also the size of the screen. If you have a screen like this one, I don't know how big it is, like 6 meters, 4 meters wide. The resolution of this screen is 180p. Why? It's my laptop. No? It's my laptop, it's 180p. 1080 pixels per inch on the height and 1090, 1920 on the width. Basically, I'm upscaling my screen from here, to the big screen. What happened? I didn't change the pixel density. So what I'm doing is making the pixels larger. That's why you don't see that define the text on the presentation, no? Because basically we are enlarging a raster file. If this file, instead of a projector that works by projecting vectors, would have worked by projecting raster, would have worked by projecting vectors, that will be ideal because we have variable scaling depends on the image that we are processing. What happened? We don't have projectors, we don't have cameras, we don't have printers that can actually produce vector files because humans see pixels, and this is how the human is created. Actually, if you look a little bit on any, like, just look for how the eye works, humans see with cones. I think it's cones and another kind of sensor we have on the eye. But basically, that are also kind of the core visual pixels inside our eye. So we have a lot of cones, and we have two types, one that sees color and one that sees shape. So that is our limit on the pixels that we can see, because the amount of pixels, natural pixels that we have in the eye are around 200, 300 cones per inch inside the eye. So, as I was explaining, more pixels per inch means more definition, means we can see things sharper, but also the file size increases exponentially because we are not talking linearly in 1D, we are 2D, so it's a grid, it's a matrix. So one side multiplies each other and the file size increases dramatically. We also need to work about color size. In computers, we have two ways of defining colors. Another different aspect is, and maybe some of you that are used to print things, you are used to another type of color space that is the CMYK. That is the 4 colors of the printers. But on the computers, we always work with 3 colors. It is RGB. And we have something defined that is color space. What is color space? Color space is the amount of colors that we can visually represent. So a camera usually captures in RGB or is predefined to capture in RGB. That is a wider spectrum of color representation. To give you an idea, even the best screen on the market nowadays can only represent up to 76%, as far as I remember. I don't know the latest products, I'm sorry, but only up to 66% of all the colors that a human can see. So the best screen that we can create right now cannot represent the all amount of colors that we can see in the nature. And actually, each one of us also sees different colors. We have different calibration on our eyes. That's why some people usually, some people is colorblind, or some ones are more prone to design because their eyes actually are better calibrated. The same, but we have like tall and short people will be the same. There are people that sees more colors than other ones. For example, it's a fact that women can see more red colors and green colors than men. That is like natural evolution that has given the superpower to women. So kind of happens the same with the color space on the computer. We have RGB and sRGB, that is short RGB color space. What we will have too is, again, is how we transmit and copy our files. Most of the people cannot feel the difference, or not a huge difference, between one color space or each other. But it makes a big change in the amount of data that we process, and especially that we send, for example, through internet or through a USB or pen drive. So we have less possible colors to show, so we reduce drastically the file size. So that means sRGB are compressed color space image compared to RGB. But you will say, I always want to have RGB. Yes, but for example, internet has some standards of communication on the image transmission. That is, the images and your browsers are always showing you sRGB pictures. That's why, for example, when you upload a picture to Instagram, it doesn't show exactly the same as you see on your screen, and doesn't show exactly the same if you look at on your smartphone screen, or on the TV screen, or on the laptop screen, because how they process the color is slightly different. So what happens if you capture, and you are using a reflex camera, and you take the picture in RGB, and just upload it to Instagram? You haven't manually changed the color space with a design program. So that means the conversion is automatic. That means the control of the colors is not as accurate as it should be. So for example, you have taken the up image, but Instagram shows you the bottom image because the color space conversion has been done automatically. This has improved along the years, and this is an exaggerated example. But it's important to know, in case of your websites, that you are uploading images. If you want to reduce file size and have like clear, true colors shown as accurate as possible, you need to change the color space of your image from RGB to sRGB. In case you are printing files for paper, printers, they don't print in 3 inks. They print in CMYK, and some of them white too. So you need to change from a 3-color space that is RGB to a 4 or 5 one. That's why, for example, Illustrator automatically, when you create a file or you save the file or you export the file, asks you for the color space to do a good color translation between your working space of your image, that, for example, is your picture taken with RGB, to a semi-YK, so you are able to print with keeping the most accurate color space resolution. Image.
Se oye algo ahora.
¿Perdón?
Se oye a Edu por de fondo.
No sé qué es eso. Vale, bueno, Oscar, no sé tú, yo entiendo también que ellos ven que que el Smart System puede ser un trigger. Lo que me gustaría saber es que ellos...
Cállate. No sé, ¿dónde estáis? ¿Qué ha pasado?
Es que es...
Se oye a Edu dentro de la conversación.
¿Dónde estáis?
Acabo de mutear a Santi.
No entiendo. Está mezclado los audios. ¿De dónde es?
A mí lo que me...
¿Estás en Bluetooth? Sorry guys, technical issues. Like, where is this guy coming from? Your headphones are mixing with this Bluetooth? What? Sorry guys, like the audio was being mixed between Bluetooth devices. That's weird. Okay, let's hide Bluetooth controls. So when we save images, raster images, we need to see what are the difference between the format. I suppose most of you are used to JPEG or JPEG-G. That is like a compressed and standardized file format. Right now, it's the most widely used all over the world because it gives a good ratio between quality and file size. Actually, that's something that was popularized again on the rise of the smartphones and mobile devices and internet connections, because we needed to transmit really a lot of information fast, and the bandwidth before, some of you that might be older, we had the really poor internet connection, like a few kilobytes or megabytes. We didn't have like fiber optic internet. So that gave the rise to the JPEG that was invented more or less in the 2000. That gives a good flexibility. But as the format states, it's a compressed image size, image file. And what happened when you compress images? Anybody has a clue on what happened? No raising hand? Okay. So what happened with compressed images is every time you open the image, you are basically uncompressing the image. So you open the image to visualize it, you uncompress the image, you see it, when you close it, it's self-compressed to reduce the file size. That gives that every time you are opening and closing an image, or copying the file, or moving from one hard drive to another one, the image is being compressed and decompressed. And that is done by algorithms of compression, that some are more efficient than other ones. But that gives a little bit of data loss. So I'm not going to show you the video because it's like 1 hour video, but if you look in YouTube, like data loss, JPEG compression through years, they run like a computer doing like super fast opening and copying files. The image is degraded. So that means that you start with an image that was like this, and slowly through 1 million saves, that means a lot because the file format is good, you finish with an image like that. And slowly the image could not be opened, or a red line just comes across the whole image and the image degrades. So actually, not only we have a problem on how we store digital data for years. Imagine how long have you been using computers? 10 years? 20 years? Like some people here, maybe 30 years? like that will be weird. Like most of people has been using computer or have a computer at home, more or less, what time we are, 20 years, 20, maybe 25 years. We don't know how to store information in the long term. For example, hard drives are prone to fail around 10, 15 years. Like one of the most stable devices that we have to store information that are Blu-ray discs, they are meant to only last like 20 years. So actually, for example, in 50 years, we have a problem. We don't know if we will be able to open the pictures that I can take today. First, because the hard drive might broke, or just because of compressing and decompressing and copying the image from one place to another one might have degraded the image. To avoid this kind of compression artifacts, we have formats that are like free or lossless formats. For example, the PNG. PNG is like a natural format of a raster file. What happened? Could be easily like 2 or 3 times larger in size than a JPEG, easily. But the PNG is a not compressed format. That means it doesn't have data loss between opening and copying files. So in general, it's all as much as you can, it's really good, or you should always try to use PNGs. But that will consume more space in your device. That's also true. A good point as is a lossless format, PNG can have like transparent backgrounds. So when you look for a PNG or a JPEG, for example, of this will be an image, this will be a blue circle. The white is empty, it's not image representation that we want to show. A JPEG will color these pixels because how the file format is defined. Meanwhile, a PNG, if you don't draw with a vector program or a raster program, these pixels in white, they will not exist. PNG only saves the data that is created, doesn't produce data on its own. That means in PNG, we can have transparent backgrounds. That is widely used to have overlay of images to show things on your web pages. And then we have like proprietary or like more extended and layered files, like TIFF and PSD. Let's go first with TIFF. TIFF is a really popular format that is able to store layers of information. Imagine that you have a large amount of folio papers, and you have one layer of paper, and you have a second layer of paper, and you have another layer of paper, the same as your paper notebook. So in TIFF formats, we are able to save images on top of each other. So it's really widely used in our raster design programs. What happened with this? That also increments the file size. We have the PSD, that is the Photoshop proprietary format for the TIFF. It's really similar to the TIFF, but it's proprietary, and Photoshop has enabled some features that only the programs are able to read. For example, we can save a definition of different color spaces for each different layer. And then we have RAW or NEF format, depends on the manufacturer. A RAW or NEF format is a raw image file. It's an image file that we cannot open directly. It will be the digital film, the same as before with cameras. We have the film roll or the film reel that is made out of like this browny semi-transparent that you need to give to the photographic shop to get it revealed with chemicals. You are not, when you take these small films, maybe from your parents, you look at the light, they have the colors inverted and they look weird, no? We have the digital equivalent, that is the raw net format. Why we have that one? Because it's the amount of information that this format can store is huge, is immense compared to our TIFF format. And this is a raw data. Is the data captured by the pixel of the sensor. That means they don't have predefined color space. they don't have predefined resolution, neither size, and neither density, and they don't have color calibrations. So it's an extended format that you need to reveal with a specific software in order to be able to see it and transform into a more popular and sharing format file, like a TIFF, PNG, or JPEG. Usually, unless you put your camera or you have a professional camera, the camera doesn't take shots in this mode by default. But nowadays, it's changing because some devices and even some smartphones are able to save raw NEF format. For example, my phone, I can go to the settings and change, please save also the raw NEF format. So I can later take that picture, go to GIMP or Photoshop, and edit it, having all the capabilities of taking the shadows in or putting more light in the image and fix images that were broken. To give you an idea, for example, something that a lot of people don't know, all the iPhones have Sony camera sensors. And you will say, okay, Sony phones are not usually like prone to be like the best image taking smartphone, no? Like everybody, most of the people think that iPhones take the best shots of all the smartphones. That's funny because Sony uses even better sensors than iPhones for their phones. What happened? It's actually how you process the image. So iPhones and all the camera sensors give you a raw image. How you process the color, if you make it sharp, or you make more definition between the pixels, or you use the color space, is what actually makes the difference of an image. So iPhones are really good because the chip on image processing, they have dedicated a lot of hours on actually how to translate your raw information of the sensor to a PNG JPEG format. So let's say iPhones edit a lot the image just by taking the picture. The picture that the iPhone takes is an already photoshopped picture. Meanwhile, a Sony, for example, phone gives you only a TIFF if one, because Sony is a hardware manufacturer and doesn't spend too much time on the software side of the image processing. For example, also happens the same with Canon and Canon and Nikon. Nikon process the images different than Canon. Canon, for example, gives a little bit of greenish red color space. Meanwhile, Nikon gives a bluish yellowish color space. That's why, for example, Nikon are usually more prone to sport cameras, like in professional worlds, for sport cameras, because the color space and how they process the image is slightly sharper for really distant objects, for example, a football player. Meanwhile, Canon and how they process the image that is slightly softer than Nikon is widely used in wildlife photography. So it's how you process the image what matters. So if you want to keep control over your whole image, you always want to shoot in RAW, but then you need to edit it. And that's usually quite annoying because you need to yes or yes, process or reveal the digital in order to see it. This is a little bit on Photoshop. We will not really go deep on this. But most of the programs, you have these options that they will focus a little bit. That, for example, when you go into Photoshop, what happened? You can edit the total amount of RAM memory that you can use. For example, nowadays, we have, I would say that most people have a big problem that we try to have as lightweight device as possible, like for example, a computer that doesn't weigh a lot. That means the specs are not really high. Meanwhile, on the phones, we are doing the opposite. We want to, and manufacturers try to sell always the most expensive hardware, more megapixels. So what happened? You have a phone that is taking a 30 megapixel. I have seen phones that even, I think there is one that takes 100 megapixel images. That is insane. This is football match scale image size. Like unless you want to print a whole building, you don't need 100 megapixels image in general. So when your computer goes slow, all these programs have actually a slider that you can change to augment the total amount of RAM memory that you can use in order that you are able to process that amount of information. Because we need to store each individual pixel in the RAM memory that is a volatile memory that the computer has to work with. And inside, when you open a file in Photoshop or GIMP, for example, you have what is resolution of the screen and resolution of the image. You can change and you can tweak each one. For example, you can make the computer work at 300 ppi for processing your image, but only show you 72. Actually, that's what you do, because you don't need to see as good as the real image is in order to edit it. That will make your editing much faster, because the computer will not slow down, because it doesn't have to show you 300 ppi. It's only showing you not even half, it's 1/4 of it. When you make a file, in general, when you want to make a new raster file, you have different things. One is the width, the height, and the resolution. That will be your image size. So in general, you don't try to put images bigger in the height of 180p, because it's actually the international shared standard for image transmission for websites. So in order, if you want to put a high definition picture, for example, on your website, and you don't want to make it weight gigabytes of storing on the servers of your image, you need to reduce not only the resolution, but also the width and the height. And in general, for internet, even if you go higher than 150 ppi, you will not notice any difference. And you can see here, for example, this image is more or less in a format that is meant to be in an online, but the color space is wrong. The best will have been to choose a sRGB, that is short RGB, the color space definition. And I think that everybody is asleep. No? Do you have any questions up to now? Yes? Okay, I'll go with mine.
That's super interesting stuff, the color, the idea, that was pretty good, but the how does it compare with Photoshop and
to be honest, Photoshop has been doing this for 30 years. And like have a big amount of like software developers working on it, and the amount of innovation that like market-wise Photoshop or like other like Adobe Illustrator cannot compare. That's a lot. Like for example, when you try to compare Rhino with Blender, I would say that Blender is slightly better, and I would say that it's more powerful. But that doesn't happen the same way. For example, Git, that is alternative to Photoshop, or Inkscape, that is alternative to Illustrator. That could be because more modeling people is more prone to coding compared to illustration or photography. Yes, so actually that really like, we say that humans should be a little lazy, and we try to go to the issue. So if you like to take photography, you don't care about how the work works, as long as it works well, you don't care about how to do it. For example, that's also true that, for example, Adobe in general suites works better in Mac, and that's a fact. You can take the same specs computer, but in Mac it works better than Windows. And you can buy two laptops, one Windows, one Mac, same CPU, same GPU, but just run different operative systems, and the Mac will go faster. That's why one of the common things that usually designers choose to use Mac for their devices instead of Windows. That happens specifically with Adobe Suite things, but not all the software. Like I will say that it's Lightroom, Photoshop, Illustrator, InDesign. In case of, for example, Premiere, I will say that it works slightly better in Windows. Depends a little bit on when the program was created and when not. Let's talk a little bit about tools here. So I have attached a few links. So when you want to upload an image to your webs, please compress it. Don't take the image from your phone and put it on your website. It's basically you are just making your website work slow without actually gaining anything at all. For example, I want to tell you it's a funny history. Before I used to work a few years ago, I worked in Seoul. They have the fastest internet connection on Earth. Like the average internet connection is 1 gigabyte. It's like almost 5 times faster than the average here. And they give you for free that one, just by having a phone. The average one in a company is around 4 gigabytes. So that means the Koreans, they are used to just upload, and Koreans in general and Japan are like kind of geeky countries, and they usually have like super nice cameras, and they have the latest models of camera recorders, etc. So the average file size for them is around like 30 to 50 megabytes for an image, because they produce images at the larger format. So they usually don't use Google too. In case of Korea, they use Naver, because they upload the image in a raw format. What happened? If you try to go to any Korean website in general, that you will not, because you don't know how to write Korean, I don't know too, but a Korean website is really heavy to load from here. It's really difficult to go to a Korean hosted website that hosts Korean content. Why? Because the file size of the web is usually on average 1 to 2 gigabytes, compared to, for example, a European one that is in around like megabyte size. And that is actually just, it's not a critique, it's they have the resources to have a super big and nice steady connection, so they don't care about compressing image sizes. In Europe, the internet speed is in different terms. And not only in Europe, but you always, when you want to make a website in a world connected planet, we want that everybody is able to access our website, no? Do you want to trust the accessibility on your website on the stability of the connection that is going to access the website? Or do you want that the website loads as fast as possible, no matter what? So, optimized web page, and I'm talking about like the minimum optimization I should do, should have like compressed image on it, should not have any uncompressed images. With that, you are able to access your website with the 3 megabyte connection at the same, almost the same speed that 300 megabyte connection, because the amount of data they are transmitting is small. And one of the biggest like weight consumers of a website are always the images and the videos. So image magic, Santi and Oscar can show you also, in case some command lines to compress images and videos. Is a little software that allows you to just compress the image. You can do the same with Photoshop, for example, or GIMP. Yes, all those softwares have something that is safe for the web. Let me open up Photoshop just to show you what it is. In case of SVG, the most common softwares are Inkscape, that some of MDF already went to, and we will go tomorrow on Fab Academy. So when you open a Photoshop, for example, here, what is save for web? Here, we already have like a lot of predefined features, like automatically change to sRGB, change to a PPI with this amount of resolution, change the total image of an image that could be like 500 megapixels on the width to 1000. That allows you to save, like what we call it, web safe images that are faster to load. Like, I suppose that most of you, if the web page takes more than 3 seconds, you usually close the tab on your browser, no? In general. Like, we are used to this kind of instant things. So, save and try to save in lightweight formats. For the ones that don't want to install software because the computer cannot, or nowadays, like with the good internet connections that we can have online editing softwares. Of course, they are not as powerful, as they don't have the feature as dedicated installed programs. What is this? This means. But this is a really good software that is online. It's Pixel, for example. Yeah? Sorry, I don't hear you.
So what's the guideline for websites? I don't know. I usually use 70p or 180p maximum. And the Pixel 3 70p. Image should weigh around like 100 kilos or 300. It is like let's see, like 150 pixels per inch, more or less not really compressed. For example, in Hitech, when you say Hitech, in the Hitech software, that allows you to say different levels of compression. You have like 1, 2, 3, 4, 7, 8, 12. If you want to choose like the not really compressed format, usually you should not wait. You should not upload images that weigh more than 1 megabyte, or try to reduce it. For example, I don't know, all my portfolio, I have like 2,000 images, like architectural images, and they are like big with good resolution. My whole website weighs 100, 200 megabytes. And I have like, I don't know, 15 years of storage data there.
So for pixels, you have Pixelar, that is a quite good online software. And for vector, in case you don't want to use Inkscape, or you don't like it, that also happens, you have like vector. I don't know, vector. So let's go a little bit deeper. This was 2D. Now we have 3D. Let's spend like half an hour more on the 3D. I focus a lot in the 2D because we have kind of the same comparison on the 3D file formats. We have, I'm not going to talk about the programs, I'm going to talk about modeling ways. We have what is called mesh and NURBS. Have you ever heard about it? Anybody? Do you know the difference? Okay, someone there knows the difference.
I could say the difference between them. Okay, my very basic description would be that one is built upon triangle and the other one is built upon polygon. I know it's very bad.
Actually, that's good. Mesh will be the 3D of the raster file, and NURBS will be the vector of the 3D file. So NURBS is non-uniform. Sorry, the name is quite complex. NURBS is the right one, yeah, and mesh is the left one. So let's start with mesh. Mesh format not only saves triangles. A mesh could be polygonal, could all be squares or like pentagons, but in general it's triangulated. A mesh saves points in the space. And by connecting the points, we create surfaces. So a mesh file, in general, will be more, will have more weight than a NURBS. A NURBS is defined by mathematical equations in 3D, and the mathematical equations of a NURBS format are usually quite complex. For example, when you should use each one of them, actually it depends, and depends on the software you use. Some softwares are only meant to work with mesh files. Other ones, and they have like or mesh modeling. Other ones, they have both compatibilities. And other softwares, they only use NURBS. For example, I don't know who plays video games, but video gaming in general, and also animation, always, and rendering is always done into meshes. Why? Okay, imagine this triangle. We have a small triangle. We want to put a texture, no? Color, to have like a run. We want to, I don't know. We want to model Buzz Lightyear. So Buzz Lightyear will be purple, white, green. So we need to define some areas with different colors. What will be easier to define? Triangles, like three-dimensional pixels, or a surface that is continuous and never ends, because it's a mathematical equation, and like it's endless and doesn't have size per se. Because here we know if this point is 0, 0, 0, and the next one is 0, 1, we know we have an scale. So in general, in animation, in rendering, in video games, they all work with meshes. Because even if they consume a lot of memory, they are really fast to calculate. And it's really easy to calculate. Meanwhile, in the NURBS, we need to actually calculate a lot of equations that are really huge. Because if the equation of a circle is already more or less complex for a human, imagine the equations of this rhino. So for example, surface, though this surface is a NURBS. Actually, I want to explain you what is the NURBS use. The NURBS name is always really complicated. Sorry, NURBS wiki. Non-uniformal ratio B-spline. Okay, that gives already a big statement. Why? Because, for example, we want to define, let's go it here. Oh, what is the presentation? Here. We want to define the surface. We will do it by a cross-section of lines, because a cross-section of lines is way easier to define than a surface. So what we will do is we will take this control point, this control point, this control point, this control point, and the computer will interpolate. Interpolate is kind of average a curve between the different control points. Doing this in cross sections, one in X, one in Y, and one in Z, will give a matrix. And now that we have three-dimensional curves in the space, we will create the average one again between all of them. That average in X, Y, and Z will actually create this NURBS surface. What happened? NURBS in general are way easier to manipulate because they have like control points of addition. And also they are easier to modify in general than a mesh. Why? Let's say I want to reduce the whole thing of this dolphin. I need to actually select only these points. So I will need to pick each point and move all of them. Meanwhile, in case of this rhino, I can take just the control point and press it, and I will reduce the, how is it? the point of the rhino. How I can clean the, I don't know how to clean. Clear on drop. So a NURBS modeling in general is CPU consuming, meanwhile a mesh modeling in general is RAM or GPU consuming. Depends, in general, most of the CAD modeling programs for 3D, they always try to work with NURBS. But nowadays that's changing because the computational power that we are reaching in these years is so huge. And right now, for example, most of your computers will have 8, 12, 16, or 20 gigabytes of memory. That is insane compared to a few years ago. That makes able to process largest amount of mesh files. So a mesh is not defined by surfaces per se. A mesh is defined by points in the space. By making the interconnectivity between those points, that is triangulation, in general, a mesh is generally triangulated, we created lines. On the lines, we can create surfaces. On different surfaces, we can create polygons. And with a polygon, we create shapes. That's how mesh format works. It's quite similar to a point cloud. Inside mesh, we have a secondary format that is not a mesh per se, that is a point cloud. For example, a 3D scan, you know, have you ever, well, do you imagine how a scanner works? A scanner actually is quite similar, a 2D scanner is quite similar to a photography. We have diodes, LEDs, pixels that reads information in a line. With a 3D scan, kind of do the same. But the difference is the points we are getting are not in an array. In general, the points that we get when we make a 3D scan are what they call point clouds. It's a lot of points located a little bit random. So how we create a surface from points? By triangulating them. So in general, those are the ways how we have to model. A point cloud is a mesh. No. A point cloud is the basic type of file, of three-dimensional file that we can create through either a 3D scan or other method. A mesh is already defined, even if the base of the mesh is there are points, the mesh defines surfaces. And the surface could be correctly oriented or not. A surface has normals. Do you know what is the normal of a surface? So for example, this table, I don't know if you will see on the camera, these computers, we have this surface. We have 1 point, 1 point, 1 point, 1 point, 1 point. This is the physical representation, for example, of a mesh. The top of this table with one surface of the mesh. This surface has orientation. Up, upside down, or up. What will be the correct orientation? How we define that what is outside of the table and what is inside the table? Because the table right now is defining a space, no? This space is defined by the surface. Okay, but the surface has orientation. We have a normal of a surface. That is a perpendicular vector of the surface, that is what my arm would be a vector pointing in that direction. That is what is defining what is outside. So what is outside and touching the normal of the table is outside the model. If I'm able to go inside and no normal touch me, I will be inside the table. That's how 3D model works with mesh. What happened? A mesh, that is something that we will see in 2 weeks in 3D printing. A mesh will be wrongly made. It could be defined by the points, perfect, but the surface could have the normality of a way. In that case, it's a broken image. In NURBS, that doesn't happen.
because we don't define surfaces. We see surfaces the definition of B-spline. A B-spline that are the curves that you see right now on the screen, or these polygons that we average, are basically curves, three-dimensional complex curves. And that is how actually we call these splines. Depends on the software. For example, Rhinoceros call it just curves, but AutoCAD call it splines. They are basically like non-equalitarian curves that are just not defined rational curves like an arc or a sphere or a circle. So for example, you want to edit a NURBS. This is the clear example. This NURBS is defined by control points, that not points, they are control points. This average control point averages the movement on its surrounding. Why? Because we are getting the average between this one and this one. So if we move this one is averaging the moving to the points, control points that are surrounding it. So I want to edit this surface, I can drag this point, and I will average the movement on my whole surface. Meanwhile, for example, in a mesh that is defined by individual points that are not strictly related to each other, just on the formation of the surface, this is what will happen. I will take the point, I will drag it, I'm only taking and actually actuating that point. So I will only modify the surface that are actually created by touching that point. Which one is better? Actually, there is no answer for that. Depends on what you're doing. For three-dimensional sharing files, it depends if you are doing engineer or architecture, or let's say you are someone that wants to actually share the file format in an editable or non-editable way. For example, if we are, let's state because it's the easiest example, we are in an engineering firm and I want to share the bolt that I'm designing with my teammate. I want that he is able to edit in the fastest way as possible, no? And in the easiest way. So in that case, I will share the file with him in a NURBS format. But I want to actually print that bolt in a 3D printer because I want to make a prototype. I don't care if the format is editable or not. Let's say if I can easily modify the format or not. I want to have like the more defined resolution on the surface. Why? For example, this, even if we visually see as a continuity, we are working with averages of curves at the end. It doesn't have a definition, a real location per se. Like this part of the surface doesn't exist. It doesn't have, if I put a dot in that surface, that dot will not be exactly defined. It's being averaged all the time on the computer, it's calculated. Meanwhile, if I select a dot in this surface is clearly defined. That surface is defined by 4 and minimum 3 points. With these 3 points, I can calculate the location. It's like GPS triangulation. So you can know exactly what is the space location of that one. So for example, mesh formats have higher three-dimensional accuracy than NURBS. So if you want to make something that is accurate or have a physical representation of it in an accurate way, you want to do it with a mesh. You don't want to do it with a NURBS. Because in a mesh, it's way easier to actually measure than in a NURBS. For example, programs like Rhinoceros, they work in NURBS and meshes. Always there are one kind of format that they are better than the other one. There usually, Rhinoceros is better in NURBS. So when you work with really big meshes, it has problem with the memory because it's a program designed to work with CPU, not with GPU. Other programs, for example, Mex Mixer, is a program that is specifically designed to work with meshes. So it's way, way faster and it's way, way easier to edit.
So kind of programs and how they work with these different formats. We have Fusion. Fusion is an engineering software, what we define as an engineering software, work with NURBS, but also can work with meshes. Actually, all the programs, in general, they can translate a NURBS into a mesh. And in general, what you should never try to do is transform a mesh to a NURBS, because you will not get a defined model. Happens the same when you translate a raster to a vector. You are not getting a perfect image on a vector. But from a NURBS to a mesh is way easier. So if you start working with a mesh, let's say you 3D scan, I don't know, your teddy bear, it's not strictly mandatory to work with a NURBS. You can use a mesh editing software to actually edit it in the easiest way as possible. Meanwhile, if you actually model, in general, when you initially model something, you always, or in most of the cases and most of the softwares, you design automatically with a NURBS. You create a circle or a sphere or a basic three-dimensional primitive, and by combining them and by modifying them, you actually create your teddy bear, for example. In general, you always try to start with a NURBS because it's way easier to modify in general than a mesh. So we have, what is it? We have Fusion. Fusion works with words. Blender actually is really good at working with meshes because Blender is a software that embeds already animation and also rendering. And actually they have created movies with this software. So it's really good at final processing of these kind of surfaces. And Victor actually is here. He will show you in half an hour a little bit more on Blender. We have FreeCAD. We could say that is the open source Fusion or SolidWorks. It's good, and it's for engineering with NURBS editing. What else we have? We have Rhinoceros, that here we have a lecture, and it's something that also we will go deeper on the clubs, so especially with Grasshopper. It's a NURBS, and also SubD, that is subdivision is a different kind of modeling that is not that popular, kind of similar to NURBS and Mesh. And we have SolidWorks, that is a NURBS editing software. In general, all these proprietary softwares, most of them, not all of them, they have their own standard formats. For example, if you work with Fusion, you will save in a F3B file. If you work in Rhino, it will save in a RAI file. If you work with Blender, I don't know the Blender file format, but each SolidWorks has its SolidWorks format file. Even so, there are international file sharing formats or standards, or there is a standardization a little bit to translate one model from one software to another, trying to get as accurate as possible without too much model changing. Standard file sharing format for a NURBS will be a step file. Step file is a standard exchange product data that basically is one of the standard file sharing formats for NURBS format. In Mesh will be STL that you might have been more familiar with. Is what is considered nowadays the standard file share format for Mesh files. STL is a quite old format, and nowadays is being replaced with, for example, OBJ. OBJ is an enhanced file format of Mesh. And what is one of the main particularities? For example, STL4 file format is really old, doesn't have a scale. So when you open a STL, it doesn't have units, doesn't have meters, millimeters. So OBJ, for example, fixed that issue. And one of the main difference between OBJ and STL is STL doesn't save something that is really important for rendering an animation, that is color. STL only saves three-dimensional surface geometry, doesn't save color grading. So for example, if you put a texture on the surface of a mesh, if you save it in STL, you will lose all that information. Meanwhile, if you save in OBJ, you will save actually the texture that is could be the color or an image associated with. Let's go a little bit deeper. And then we have parametric design softwares that in general, they could be at the same time mesh and NURBS. They are not, they don't have a design format, but it's a way of drawing in a file format. So parametric design is a model where you actually don't draw circles, but you draw a set of rules. In general, is what we call visual coding. It will be visual scripting, or could be directly coding. So you associate, for example, here we have a lot of circles. We don't draw physically the circle. We associate center location of circles, and we associate values with the diameter of the circles. So that means we will have, like in this case, I don't know, 200 values for each one of the circles. Or could be a set of rules that define the diameter of the circles. So it's a completely different way of modeling parametric, and this is not only Grasshopper. Fusion has also a parametric design part that Yusef will show you. We have also, for example, OpenSCAD. OpenSCAD is a software that is a parametric software that you don't draw. You never draw a sphere. You don't draw a rectangle. You don't draw a square. What you, in case of OpenSCAD, you write the code, the line of code that is calling the square component. And a sphere, what defines a sphere? Its location? No. What is the center of the sphere? That will be one value. It will be in the region, 0, 0, 0. And what else defines a sphere? It's another value. Radius. So instead of defining or drawing physically the sphere and making bigger or smaller, you define with parameters that will be its location and its radius. But you could do this with all the different shapes. Circles, spheres, box, all the kind of primitives, dodecahedrons, whatever. And the combination of both is what makes actually your geometry. So in general, in a parametric design compared to a traditional modeling, you don't do it gradually. You don't build a geometry, and then you add another geometry, and then you add another geometry, and you make Boolean operations between them. What you set up is a set of rules on how one thing relates to each other. So in parametric design, one of the most difficult parts to do, it gets the abstraction. For example, anybody can guess how this could have been made? So the logic set of rules of this is not drawing the circles and put them in place. It's actually, first, I'm defining a square array of squares of 2 by 2, for example, and I want to have 20 grids on X and Y. I have an array. I will locate circles in the points of the array. So I'm filling all the array with circles. When you have filled the array with circles, what I will do is create this point, in this point, for example, and this point manually. I will create 4 points that will be attractor points. So now that I have this point, I will measure the distance between this point and the ones that are close by. As close as one point is close to each other, the diameter will be smaller of that circle. As long as the point distant to each other is larger, the diameter of the circle will be larger. So in parametric design, what you need to change is completely your mindset. Is you need to create a set of rules that makes everything work. So actually it's quite complicated. It's the most complicated part. Abstract the geometry that you want to create into a set of rules, not drawing it directly. But that gives the option, especially with the help of data fabrication, that you will go during the next months, to create a way more complex designs. And this is actually what happens up in the parametric design process versus the amount of work. And I will show you this with just one image that I already showed you to some of you. You want to create an array of boxes and you want to print it. Okay, you create it manually. It takes you 1 hour and you print it. And now it's not
Hello. No sé si me escuchan o no. Es que
con el mío, tío. ¿Quieres la password? Toma, te tengo
Hello. Can you hear us?
Yeah.
Hola, hola, sí.
Just for you.
For example, this is Sketchpad. It's an online page that allows you to, for example, upload three-dimensional files. A lot of you this week will actually design something, and actually your weekly task is to design and model your final project, and in case of embedded students, it's your intervention. So we want you that you do a 2D, for example, a vector or raster file of your final project, your intervention, and you also model it, and if you can, and you are willing to, animate or render it. So let's say you want to show your three-dimensional file. How you will do it? By taking screenshots or a video. There are services, for example, like Sketchpad, here, that allows you to upload a 3D model and visualize it in live. And the best point is you cannot not only do it through their website, as you are already experts in HTML, you have snippets of code that will actually put a 3D visualization window inside your websites. So you can visualize 3D models with full interactivity inside your website without actually having to actually put. So, for example, this is a 3D scan of Balaura. And as a 3D scan, you can see here, you have triangulation.
This meeting is being recorded.